Progressive die stamping is a versatile process that allows for efficient, cost-effective manufacturing of numerous parts and products. It produces high-volume sheet metal components of varying shapes and sizes, effectively reducing production costs and shortening lead times. During the progressive die stamping process, a stock strip moves the part through a series of individual stations, each performing its operation on the workpiece, such as flanging, punching, forming, and drawing. As the workpiece advances through each station, it progressively assumes the intended dimensions and contours. The stamping process planning starts with an unfolding of the 3D model of the stamped metal part to produce a flat pattern or blank shape. The final part must be developed or unfolded step by step from its initial form until the exact initial 2D shape is achieved. VISI uses Hexagon's FTI forming suite, scientific physics-based technology, to develop accurate blank shapes based on forming process and material properties while accounting for stretch and deformation due to induced strains realized from the 3D product geometry. Next, stamping operations such as forming, drawing, bending, and piercing are planned, and operations are assigned to die stations. The resulting plan is called a strip layout, which guides the subsequent die structure design. Strip design is the most challenging task in progressive die design, and VISI helps guide die makers to engineer the proper sequence. A progressive die's productivity, accuracy, cost, and quality mainly depend on the strip layout and stamping process. Placing 3D flanging, forming, bending, piercing, and cutting operations into the strip is seamless. The strip is easily updated to accommodate a reduction or increase in the number of operations. VISI offers unique validation tools and predictive simulations to assist the operator in assessing the performance of the strip design. For a sheet metal stamping to retain its shape, it must be adequately strained. This means you must form the metal in a way that imparts work hardening. If you don't have adequate strain, the material wants to return to its initial state. We call this effect springback. Springback is one of the most complicated behaviors to master and control. Many factors influence it, including material properties, thickness, geometry shape, forces, and strain distribution. Compensation represents a countermeasure for springback in the metal part after forming or flanging operations. Compensating a tool means morphing the initial nominal tool surfaces based on springback measurements. VISI has an excellent predictive tool that not only can simulate springback, but also has a solution to compensate for the springback using 3D geometrical surface morphing, which uses the displacement vector field of the nodes before and after sheet metal springback. Most stamping dies have several standard components, including die plates, shoes, die sets, guide pins, bushings, heel blocks, heel plates, screws, dowels, and keys. VISI supports standard parts libraries from all leading progressive die tooling components suppliers and cloud-based services. The proprietary parametric component library enables both quick and accurate placement of each standard component and ensures that modifications can be made at any stage during the project. The EDM process allows for high accuracy, particularly for complex, precise shapes that are hard to machine. Wire EDM can be used for any conductive material, including hardened workpieces and metals that are challenging for traditional machining techniques. Complex punch apertures and the corresponding solid punches are efficiently manufactured with seamless integration to wire EDM. Keeping the model within the same product environment throughout the design cycle, from design to manufacture, will guarantee data consistency and significantly smooth the design process. In transfer die stamping, rather than feeding the metal part through a series of stations, a mechanical transport system transfers the part from station to station. The initial blank shape is first separated from the metal coil, allowing it to be freely transferred and moved through several stations that finish or partially finish the part or parts. Unlike a progressive die, the parts do not stay connected from one station to the next. Instead, a transfer mechanism is required to move the parts from one station to the next. All the same operations performed with progressive die can be performed for transfer or line dies using VISI.